Now see next question, question number 8. A of -2 3 4, B of 1 1 2 and C of 4 -1 0 are 3 points. Find the Cartesian equation of the line AB and show that the points A, B, C are collinear. So here we have to find equation of line AB, and in second part we have to show these 3 points A, B, C are collinear. That means we have to find the equation of line AB. If this point C satisfies the equation of line AB, that means that point C also lie on that line. That means that 3 points are collinear. So first we find the equation of line AB in Cartesian form, because equation are in Cartesian form. So write in solution the Cartesian equation of line passing through A of x1 y1 z1 and B of x2 y2 z2 is x minus x1 upon x2 minus x1 is equals to y minus y1 upon y2 minus y1 is equals to z minus z1 upon z2 minus z1. So here coordinate of point A are -2 3 4. So we write here, therefore A of -2 3 4 is equivalent with x y z1 x1 y1 z1, and B coordinate of B are 1 1 2, that is we consider x2 y2 z2. Now substitute the value of x1 as -2, x2 as 1. So similarly substituting the value of y1 y2 z1 z2, we get the required equation of line AB. Therefore required equation of line AB is x minus x1. So here x1 is -2, so we write x minus x1 upon x2 minus x1, x2 is 1, so right here 1 minus -2 is equal to y minus y1, y1 is 3, y2 is 1, so 1 minus 3 is equal to z minus z1, z1 is 4 upon z2, z2 is 2, so write 2 minus 4. Therefore here minus minus get plus, x plus 2 upon here minus minus plus, so 1 plus 2 is equal to y minus 3 upon minus 2 is equal to z minus 4 upon minus 2. Therefore x plus 2 upon 3 is equal to y minus 3 upon minus 2 is equal to z minus 4 upon minus 2. This is required equation of line AB. Now we have to show this point C also lie on this line. That means that point also satisfy this equation. So we substitute here. Here C is coordinate of point C is 4 minus 1 0. Therefore when x is equals to 4. Now in this equation we substitute when x equals to 4, we get here x plus 2 is equals to 3 is equals to, when we substitute x by 4, we get 4 plus 2 upon 3, that is 6 by 3 is equals to 2. Now when y is equals to -1, when y is equals to -1, from this we get y minus 3 upon minus 2 is equal to, when we replace this y by -1, we get here -1 minus 3 upon minus 2, that is -4 by -2, which is plus 2. And when we replace, when z is equals to 0, from this we get z minus 4 upon minus 2, which is equal to 0 minus 4 upon minus 2, which is equal to -4 upon -2 is equal to 2. That means for on the value of x, y, z, we get value 2, 2, 2. That means this point C satisfy the equation of line AB. That means this point C lie on line AB. So the points are collinear. Therefore, the points capital A, capital B, capital C are collinear. So in this way you can write the answer. Now see question number 9. Show that the lines given by x plus 1 upon minus 10 equals to y plus 3 upon minus 1 equals to z minus 4 upon 1 and x plus 10 upon minus 1 equals to y plus 3 upon y plus 1 upon minus 3 equals to z minus 1 upon 4 intersect. So we have to show that these two lines intersect each other. That means they have common point. Also find the coordinate of their point of intersection. We have to find the coordinate of the point of intersection. So first we show these two lines are intersecting. So we consider here x plus 1 upon minus 10 is equal to y plus 3 upon minus 1 is equal to z minus 4 upon 1 is equal to lambda. So we note this as equation number 1. We say this as lambda. So from this we can calculate the value of x in terms of lambda, value of y in terms of lambda and value of z in terms of lambda. So we write here, therefore x plus 1 upon minus 10 is equal to lambda implies x plus 1 is equal to minus 10 lambda. Therefore x is equal to, after transferring this 1 to right hand side, we get minus 10 lambda minus 1. This is x coordinate. Now we find similarly y coordinate. Therefore y plus 3 upon minus 1 is equal to lambda. This implies y plus 3 is equal to minus lambda. Therefore y is equal to minus lambda minus 3. Therefore now see the third value, z minus 4 upon 1, z minus 4 upon 1 is equal to lambda implies z minus 4 is equal to lambda. Therefore z is equal to 4 plus lambda. Now this value of x, y, z are the point on this line. So we write this as, therefore minus 10 lambda minus 1, then minus lambda minus 3, then 4 plus lambda, 4 plus lambda. Similarly we consider this second line and we consider these ratios as mu. Therefore x plus 10 upon minus 1 is equal to y plus 1 upon minus 3 is equal to z minus 1 upon 4 is equal to mu c. We note this as equation number 2. So we equate this value of x, y, z with mu. So we write here, therefore x plus 10 upon minus 1 is equal to mu. That implies x plus 10 is equal to minus mu. That means x is equal to minus mu minus 10. This second value, therefore y plus 1 upon minus 3 is equal to mu. This implies y plus 1 is equal to minus 3 mu. Y is equal to minus 1 minus 3 mu. Now see third value. Z minus 1 upon 4 is equal to mu implies z minus 1 is equal to 4 mu. So we get z is equal to 4 mu plus 1. Therefore point on this second line we write in terms of mu as, here first x coordinate is minus mu minus 10, second y coordinate is minus 1 minus 3 mu, and third is 4 mu plus 1. Now we know that when two lines intersect, they have common point. So if we consider these two lines intersect, then this point must be equal. So we write here, therefore minus mu minus 10 minus 1 minus 3 mu or mu plus 1 is equals to minus 10 lambda minus 1 minus lambda minus 3 4 plus lambda. So when we equate x coordinate with x coordinate, we get minus mu minus 10 is equals to minus 10 lambda minus 1. Similarly, when we equate this second, we write here minus 1 minus 3 mu is equals to minus lambda minus 3, and for this last 4 mu plus 1 is equals to 4 plus lambda. So we get the equation in terms of mu and lambda. So we solve this simultaneous equation first. So we write this equation as, when we transfer this minus 10 lambda to left hand side, we get plus 10 lambda minus mu. After transferring this minus 10 to right hand side, we get plus 10 minus 1, which is 9. This is equation number 1. Now see this second, minus lambda transferring after left hand side, we get plus lambda minus 3 mu. Plus lambda minus 3 mu is equals to, when we transfer this minus 1 to right hand side, we get plus 1, minus 3 plus 1, we get minus 2. So this is equation number 2. And for last, we transfer this lambda to left hand side, we get minus lambda plus 4 mu is equals to, after transferring this 1 to right hand side, we get 4 minus 1, which is 3. So we solve equation 2 and 3. And equation 2 and 3. So after adding equation 2 and 3, lambda minus 3 mu is equals to minus 2, minus lambda plus 4 mu is equals to 3. So this plus lambda minus lambda get cancelled. 4 mu minus 3 mu, we get mu, minus 2 plus 3, so we get here 1. So mu equals to 1. Now substitute mu equals to 1 in any one equation, in 2 or 3. So we put mu is equals to 1 in equation second. So this implies lambda minus 3 into 1 is equals to minus 2. Therefore lambda is equals to, after transferring this minus 3 to right hand side, we get plus 3 minus 2, which is equals to 1. That means when mu equals to 1, lambda equals to 1. Lambda equals to 1. Now after substituting lambda equals to 1 and mu equals to 1 in equation 1, if this equation is satisfied, that means that two lines intersect. So we substitute, put lambda equals to 1 and mu equals to 1 in equation 1. Therefore we consider here LHS. LHS is equals to 10 lambda minus mu. So we write here 10 into 1 minus 1, which is equals to 9, which is equals to RHS. That means when we solve equation 2 and 3, we obtain the value of lambda and mu. If we substitute that value in a remaining equation, if that equation is satisfied, that means that two lines intersect each other. So we have to find the coordinate of point of intersection. So we substitute these values in any one point, so you can obtain the point of intersection. So we write here, therefore point of intersection is. So when we substitute mu equals to 1, we get minus 1 minus 10, which is equals to minus 11. Here minus 1 minus 3, so we get minus 4. Here 4 into 1 is 4, 4 plus 1 5. So in this way we get the coordinate of point of intersection. If you substitute value in lambda found. Here also you get the point of intersection as -11, -4, 5. So in this way we find point of intersection. Now see question number 10. A line passes through 3, -1, 2 and perpendicular to the lines r bar equals to I plus j minus k plus lambda into 2i minus 2j plus k and r bar equals to 2i plus j minus 3k plus mu into I minus 2j plus 2k. Find its equation. Now we have to find the equation of a line passing through this point and perpendicular to these two lines. So these two lines are in the form of r bar is equals to a bar plus lambda into b bar, and this equation r bar is equals to, suppose we say here, c bar plus mu into d bar. That means this value of vector b is 2i minus 2j plus k and value of vector d is I minus 2j plus 2k. These two vectors are parallel to the given line. Suppose this is given line, then vector parallel to this line is vector b bar and vector parallel to this line is vector d bar. Now if these two lines are perpendicular to required line, suppose this pen is a required line, these two lines are perpendicular to this required line. So when we take cross product of these two vectors, we get a vector which is perpendicular to both. That means that perpendicular vector and this perpendicular line is parallel. So in question, in or through which point that required line is passed is given, so we have to use here the equation of line passing through a point and parallel to a vector concept is used. So first we find the cross product of these two vectors, that will be perpendicular vector, and that perpendicular vector is parallel to the required line. So we have to find here value of d bar cross and d bar first, and from that we write the equation of a required line. So here we consider, let b bar equals to 2i minus 2j plus k be the vector parallel to line r bar is equals to I plus j minus k plus lambda into 2i minus 2j plus k, and b bar is equals to I minus 2j plus 2k be the vector parallel to line, the second line parallel to line. R bar is equals to 2i plus j minus 3k plus mu into I minus 2j plus 2k. So we first calculate the cross product of these two vectors, and that vector obtained is parallel to the required line. So we find d bar cross d bar. So calculate this determinant. We get I cap in bracket minus 2 into 2 is minus 4, minus get plus, so 2 into 1 is 2, minus j cap in bracket 2 into 2 is 4 minus 1 into 1 is 1, 4 minus 1, then plus k cap in bracket 2 into minus 2 is minus 4, minus plus, so we get here minus 4 plus 2 which is minus 2i, 4 minus 1 is 3, so minus 3j minus 4 plus 2 which is minus 2, so we write minus 2k. This vector is perpendicular to given lines and required line is perpendicular to these two given lines, that means this vector is parallel to the required line. Therefore let a required line pass through point -3, -1, 2 with position vector Ci minus j plus 2k and parallel to vector minus 2i minus 3j minus 2k. So we write here r bar is equals to a bar plus lambda into b bar form. Therefore r bar is equals to, here in place of vector a we have value 3i minus j plus 2k, 3i minus 2j, 3i minus j plus 2k plus lambda into, in place of vector b we have the value minus 2i minus 3j minus 2k. So this is a required equation of line. Therefore this is a required equation of line passing through the point 3, -1, 2 and perpendicular to the given two lines. Now see question number 11. Show that the line x minus 2 upon 1 equals to y minus 4 upon 2 equals to z plus 4 upon minus 2 passes through the origin. So we consider here origin as O. O is origin with coordinate 0, 0, 0. So given equation of line is x minus 2 upon 1 is equal to y minus 4 upon 2 is equal to z plus 4 upon minus 2. If this line pass through the origin, that means the point O satisfy this equation. So we substitute x is equal to 0. Therefore put x is equal to 0. That implies when we put x equals to 0 in x minus 2 upon 1, we get 0 minus 2 upon 1 equals to minus 2 upon 1 is equals to minus 2. Therefore put x, then next put y equals to 0. That implies for this y minus 4 upon 2 which is equal to 0 minus 4 upon 2 which is equals to 0 minus 4 is minus 4 upon 2 which is equals to minus 2. Therefore put z equals to 0. That implies z plus 4 upon minus 2 is equals to 0 plus 4 upon minus 2 is equals to 4 upon minus 2 which is equals to minus 2. So for value of x equals to 0, value of y equals to 0 and value of z equals to 0, we get value minus 2, minus 2, minus 2. That means this point O, that is origin, satisfy the given equation. Therefore the given line passes through origin. So in this way we can prove the given line passes through the origin.